Thank you, Eric. That was very good. So today you're going to be confronted with the veritable fire hose of information. And I'm going to be the first to start spraying you with a lot of it. So please be ready. There's a ton to cover and not a lot of time. So I don't really have time to tell jokes. Eric did a great introduction. ECWise is my primary affiliation. Through ECWise, I get to be acting VP or CTO of other companies who are our clients. And with that, we still have some bandwidth. We develop products for those companies and help them secure both those products and their infrastructure. And we've got folks kind of all over the place, just like MongoDB does. I'm really impressed by how well they run a big distributed organization. So the things we want to learn about today are really kind of basic security things. What are the types of issues that you need to deal with in a security space, especially when you're managing databases? And specifically with respect to MongoDB, we're going to get into how to set up database instances, how to set up encryption on the wire so that the data that's flowing through the pipes to and from the databases, between the databases, is not able to be read in plain text, how to manage users' roles and privileges. There's a concept that was introduced in, I believe it was 3.5, called read-only views. Those can be used to provide some security in your applications. And then security is really contingent upon having a multi-level strategy in your organization. You're not going to solve your security challenges just by doing things that I tell you to do with MongoDB. You need to talk to other folks in your organizations, and we want to help equip you to do that. So there's a number of attacks that have become common, and I'm sure you've read about them all. Last year, ransomware was really big, and there was in particular a ransomware attack on MongoDB databases early in the year. Turned out those MongoDB databases did not have basic authentication enabled. So there's like step one we're going to talk about is just turning that on. There's a whole series of other types of attacks that are performed. Sql injection is kind of like the grandfather of attacks on databases. Obviously, relational databases have been around a very long time. They proliferated in the internet era. People weren't thinking about security, and the attackers who thought, there might be interesting data back there, came up with a number of strategies to inject queries that the originators, creators of the databases hadn't anticipated. It allowed them to extract a lot of data. Nowadays, there's ways to do that with JSON and so on. You're going to want to talk to your application developers to make sure they're not doing things that could allow that. My favorite word in the cyberspace is steganography, which means embedding data in benign-looking files like MP3s or image files, and using those files as carriers to carry that data off of a target's network. DDoS is one of many acronyms in the security space that I'll explain. Distributed denial of service, how to essentially shut down your operation by spamming you with so many packets that your system can't handle them. We've seen many instances over the last few years of political destabilization attempts by nation-state actors and compromise of critical infrastructures like utility systems, nuclear power plants, and so on. If you're using MongoDB to run a nuclear power plant, and you may be, you're going to want to be very careful about how you protect that data. Massive data theft typically is carried out via a whole series of strategies that are kind of described by the term advanced persistent threats. I've got some references. I'm not really going to go into it, but these guys are really well organized. They operate in teams. There's a whole series of phases they go through before they actually start exfiltrating data off of your networks. So these are the kinds of things you want to avoid in your environments. And to avoid them, I'm going to spend a little while talking about common weaknesses that one sees in information systems, and then some of the kind of general strategies to mitigate them. Then we'll go into the specifics of how to do that in MongoDB. So the first set of weaknesses has to do with access controls. And as I pointed out a second ago, enabling authentication is really the first mitigation for the weakness of not having strong access controls. And considering having two-factor authentication or some sort of identity management system to ensure that the people who are logging onto your systems are really who they say they are, that's an important thing. Many organizations give out privileges fairly liberally for access to their systems. There's this concept of least privilege, which means only give people enough rights to perform the tasks that they really need to do. And that really applies very aptly to database-oriented systems. So that's an area we want to talk about with roles in MongoDB in a little bit. There's multiple MongoDB options for both authentication and authorization type strategies, which we'll get into. And then privileged service accounts, the accounts that get to go in and manage your servers and manage your databases. A lot of organizations grant those to people or contractors, and then those people or contractors leave the organizations. They never revoke the privileges. They never disable the accounts. When attackers get into your networks, the first thing they do is look for those kinds of accounts and try and use them to get access to targets of rich information. So you really want to manage those and use role-based access control, monitor the use of those accounts, so on. So the next area we talk about is surface area, which is how much information is there and how broadly is the area through which somebody who wants to get to it can come in. And controlling information in the modern organization is really a challenge because we now have the concepts of operational databases, operational data stores, data warehouses, data lakes, and these are just increasingly large aggregations of information that is put there so that your organization can make better use of information so that it can make better decisions. But the problem with that is that as it goes through, as the information goes through all these chains, it ends up in this lake through all these rivers. Who is governing that data? Who is identifying where the sensitive information is that somebody who is looking for information that they can then take out of your organization and sell in the black market can find? So this becomes a real inventory challenge and a control challenge. Traditionally, we have the problem of storage media not being secure. I was talking to somebody last night, and we're saying, well, with the cloud, that's not as big a deal as it used to be, because if you put your data on MongoDB Atlas, it's going to be hard for someone to walk in and steal a hard drive. But for those organizations that are still running data in their data centers, or maybe they have development servers in their data centers, that could be a concern. So there's really a lot of information available. We don't archive. We don't remove data after it's no longer used. So putting in place some processes around that is something you want to think about. Devaluing your data through encryption, which is not a feature of Community Edition, so I won't talk about it in detail, but it's a feature of Enterprise Edition. Tokenizing, which is the concept of not putting national identifiers or health insurance information into the accessible data, but only putting in tokens and putting the sensitive data in a secure vault and referencing it from there is a strategy you might think about, and then using masking in development and test environments. Finally, common practices. Common practice number one is failing to apply patches. Now, in the MongoDB world, applying patches isn't all that painful. So you want to stay up to date. Operating systems and databases in general, every time there's a patch, there's typically some vulnerability that has been identified and is being patched. So people who want to get into systems and do things that you don't want them to do are reading reports of all these vulnerabilities, which are publicly accessible through the CVE database on the internet. And if they find that you're running a 2.6 version of MongoDB or an old version of Linux, they're going to find out what the vulnerabilities are, try to exploit them. So you want to create a patch-friendly environment where you can apply your patches effectively. You want to disable risky database features, which in MongoDB means doing no scripting, so people can't run scripts and do those no Sql injection exploits that I mentioned earlier. And then there's this whole area of application security, which isn't specific to the database, and we won't get into it in detail, but you want to talk to your application developers and ask them, are you familiar with OWASP, the Open Web Application Security Project? Have you looked at the recommendations they make for how to build software that is secure? Have you considered using their libraries that are very useful for doing standardization of text inputs in web applications, for instance, to make sure that the injection possibility isn't there? And then having some visibility into your database activity is good. There's a number of ways to do that. Logging is the basic way, of course. With logs, then you have a log management challenge. But in the enterprise, there's a number of products like data loss prevention products and security information and event management products that allow you to aggregate a lot of the information that's coming out of the databases and is traveling over the network and identify behavioral anomalies where maybe there's a lot more traffic passing between two nodes than there normally is, or there's a lot of file download activity, which might indicate that something's amiss and that you'd want to look into it. So that's another example of where you're going to need to work with other folks in your organizations to create a holistic view of the security environment. So with that, that kind of brings the general part of the talk to an end, and we're going to start talking about MongoDB specifics. And the first is, how do we securely connect the client to the server and the servers to one another? Because typically in a MongoDB installation, you're running multiple servers where you're doing replication between the servers, and there's data flowing both in the data center and between the clients and the servers. Securing your connectivity is an approach to reduce that surface area that I talked about earlier. And we'll talk about TLS, which is transport level security, the successor to SSL. We'll walk through enabling it, and we'll see some configuration options. So again, acronym laden. Let's see, do I have a pointer? Yes. Acronym label a laden area. CA stands for Certificate Authority. CSR stands for Certificate Signing Request. PEM stands for Privacy Enhanced Email, although when we talk about PEM files, they're not privacy enhanced email files. They're those package files that contain keys and certificates. So this is kind of the hierarchy that MongoDB uses for TLS. At runtime, what's happening is that the server is presenting its credentials using the files referenced in the -SSL CA file and -SSL PEMKey file parameters when you start up. And the client is presenting its credentials, and they're using those credentials to establish a trust relationship, because TLS connectivity is all about trust. Authenticating that the server you're talking to really is the server you intend to be talking to, and the client that is making the connection is really the client that it pretends to be or contends that it is. And then based on those credentials being exchanged and verified, a secure connection can be created between the client and the server. To get there, you have a certificate authority. Now, you can create a local certificate authority, and a certificate authority is a service or software that verifies the certificates that include the authentication keys. And it used to be, it's funny, the biggest certificate authority that's commercial is based in New Jersey, not very far away. I just found that out yesterday. Back in California, there is a kind of an open source certificate authority called Let's Encrypt, which is kind of a new thing. Up until the last couple of years, you actually had to pay to buy public certificates. You can also install a local certificate authority on your servers. And for the examples, we'll show that. But the process goes through creating a key on your server and your client, and then generating a certificate certificate verification request, and then submitting that to the certificate authority, and that will then generate your certificate file. And then you concatenate the key and the certificate together to get the PEM. So logically, what you're trying to do is protect the communication that runs between the client, driver, and the database, making the create, replace, update, and delete calls, and the internal traffic between the servers. So here's the code level or script level view of what we just talked about at the kind of map level. And here we are creating a certificate authority, and we're using OpenSSL, which is very easy to get. So who runs Windows? Anybody run MongoDB on Windows? So you can run Ubuntu under PowerShell. And you can run all this stuff on Windows. So we all live in one world now, and we ought to get used to it and get along. So you use OpenSSL to generate your RSA key authority, and you specify what your key protocol is going to be, which here is AES 256. Create your certificate using the OpenSSL request command and say, I want to create an X509 certificate, which is the PKI certificate standard. Create your key file and certificate signing requests for each server. Now that relies on using a distinguished name. A distinguished name, if you're familiar with Active Directory or LDAP, is the naming standard that's used to identify specific resources on a network. And it consists of country, state, locality, organization name, organization unit, common name, email. And you can use that, so when you do the request command, it'll prompt you for the components of the distinguished name. Each of those components is called a relative distinguished name, for what it's worth. I've got references kind of sprinkled throughout, so if you download the slides, these things that look like links actually are links, and there's some references at the end. So then you make your signing request by using the OpenSSL to pass the keys to the server, the certificate authority, with the certificate signing request, get the certificate back. And at that point, you're ready to create your PEM files, which are the things that MongoDB will use at runtime in order to establish the TLS connection. So that's simply a concatenation of the key and the cert file, and copying that into the configuration file. And then in your MongoDB config file, you're going to set up an SSL section, indicate the mode, can be require SSL, which is kind of recommended for production applications, but we can understand that in development or test, you may not require SSL. And then specifying the location of your PEM key file and your certificate authority cert. I'm not going to walk through the client-side PEM. It's a subset. With the client-side PEM, we assume we already have the certificate authority in place. So we're kind of good to go. The only thing I'd mention here is that OpenSSL does have a command called -inform parameter. So if you do a -inform on the PEM, it will give you back the distinguished name. So if you want to see what the distinguished name is in a PEM when you're troubleshooting, because if you're like me, you'll not get this right the first time, and you'll have to troubleshoot on your clients or your servers to make sure that the pieces are correct, and this is a good way to verify that you've got matching or matching names in all of your little pieces of the distinguished name. So then once your configuration is all set up, you can restart your servers. Very simple to restart a server. You all know how to do that. And then you provide the cert to the client and connect using Mongo-SSL, indicating who you're connecting to and what key, where the PEM file is and where the cert file is. And that's the shell way to do it. We'll now see common code. Do we have any programmers? Python programmers? No, really, wow. So Python's a pretty popular language these days for writing MongoDB apps. This example kind of aggregates all of the things we're talking about today, role management, authentication, and SSL connections. But the key part from an SSL standpoint is that when you're going to do the authorization, you're calling a get database function, and that get database function identifies where the cert is by calling the config function to read the config file, and then builds URI to the database and returns an instance of the Mongo client and sets SSL to true and sets up the certificate path and creates the connection. So it's not, you don't do this through the shell if you're writing applications. You do this in your code. And we've got examples for Java and I think one other thing in the appendix. So that should cover us for TLS. So now we can talk about authentication. In MongoDB Community Edition, there are two strategies you can use for authentication. The first is challenge response, which is submitting a username and password and getting a response from the server if it's valid. And the second is using the X509 certificate structure that you created for SSL. So if you're in an organization that uses LDAP and you have a number of MongoDB applications and instances, you'd want to consider using X.509 because then you can use the same certificates that you create for your users to connect to multiple databases. If you're supporting public users and you want to assign them individual accounts and you're using Community Edition, you may be more likely to use challenge response. And if you're doing public, you might want to also consider going to Enterprise Edition because you have more authentication options. And you can go to probably, there's a session on authentication options in Enterprise. The big difference from a functional standpoint is if you're using the Scram SHA-1, SHA-1 is a hashing algorithm. The authentication is being done in the MongoDB admin database, whereas when you're doing certificate-based authentication, it's authenticating against certificate files. So when you get your MongoDB, your fresh MongoDB install, you start it without access control, and you connect. You then restart with access. Then you connect and you create your user administrator. And here's our first example of a role. So there are a number of built-in roles. We'll talk about them, but we're giving this administrator the most liberal role, user admin any database, so they can pretty much do anything. And then we restart the database with security.authorization enabled in the conf file. And now we have a database that requires authorization. It requires somebody to log in. And so that user administrator can log in using the shell and passing in that set of credentials that was created and having a secure connection, as we discussed. And they can then create additional users who have various roles. In the certificate case, you're basically leveraging the certificates we used before. One of the advantages of certificate-based authentication is that it's doing authentication between the members in the replica set, as well as doing authentication of the client users who are logging into the database. And then we're establishing trust relationships based on the same key files and certificate authority files. So it's a similar process of you've got your certification authority that you use to create your TLS. You have to have TLS enabled in order to use X509 authentication. You create your certificates for all of the members of the replica set and all of your clients. The server and client certificates must differ in the organization part of their distinguished names. In a replica set, the organization name and domain components must match. So again, you start without access control, initialize your replica set, update your config, and then restart in X509 mode using a command. That'll look like this with set509 enabled, and you're setting cluster auth mode to indicate that you're authenticating inside the cluster, and you're identifying where the cluster file, PEM file is. Those are really the key parts to it. And then, so from the client standpoint, when you're logging in, the Scram SHA-1 login is pretty simple. You're specifying the admin database as the authority. You're specifying Scram SHA-1 as the mechanism, and then you're passing in a user and password. And then digest password true just tells the client to hash the password before it submits it to the server. In the X509 case, you're specifying that you're doing the authentication externally and that the protocol is MongoDB X509, and then you're passing in that distinguished name as the identity of the user making the connection. At that point, you can perform whatever other functions, assuming that that user is authenticated. So next, we'll talk about user and role management. So users have been able to authenticate, and we have more than one, and they may do different things. So we want to address that problem we talked about earlier, of people having too many permissions in your systems. So we want to set up our users. We want to set up roles for services as well as for users, and we want to enforce least privilege for services as well as for users. And we want to bind users and roles, or you may want to bind users and roles in subnetworks using the new authentication restriction capability. So in the MongoDB world, a permission is allowable action on a resource, and a set of permissions defines a role. And then a user can have one or more roles. There are a number of built-in roles. So they are kind of user roles like read, read-write. There are administrator roles. There's cluster administrator roles. There's backup restore roles. And then you can define custom roles and assign them to users. Now you don't get to create custom roles in MongoDB Atlas, by the way. Talk about MongoDB Atlas a little bit. There we go. We built a little clinical app that is based on the HL7 standard for healthcare interoperability. So if you're at all familiar with the healthcare space, these are standard roles and objects in the healthcare space. And you can see that the first thing that one does in thinking about roles is to figure out, okay, which roles should have access to which objects, and what kind of access should they get? Create, update, delete access, or read-only access, or no access. So here the pharmacist has, well, read access to encounters and to medication orders. Should have create, update, delete on medication orders, as well as on medications. But that gives us a way to control, by creating roles for each of these folks, who gets to see what. So create role is a command in MongoDB, and you define the name of the role. Here we're defining a scheduler role, and the privileges for that role are 2. So one privilege applies to the scheduler patient collection in the mini-clinic database, and that allows that role to perform find actions. The second privilege is the allows find, insert, and update on the encounter collection in the mini-clinic database. So 2 privileges for the scheduler role. And then we added authentication restrictions, which are new. And authentication restrictions bind a role to an IP address. And it allows you to bind the role to a particular pair of IP address on the client and server. So a user definition is very similar, and you can use authentication restrictions on users as well as you can use them on roles. So it's a little bit redundant to use them on both, but for illustration purposes, there it is. But here we're assigning this user scheduler to the scheduler role. And a user can be assigned to multiple roles. So next, we're going to talk about some general considerations for setting up your MongoDB databases. Good idea to put your database on a separate subnet that's not accessible to the internet, so people can't get directly at it. How many folks are putting their databases in the cloud? Handful, okay. I mean, various cloud providers handle a lot of this for you because they have things like virtual LANs and virtual private clouds that protect the networks that you're putting your applications and your databases on. We recommend having dedicated operating system users for both the application services and database services, so that makes it a little harder for those bad actors to get at them. Here we've got our MongoDB, whoops, what did I do? Do you know what I did? Where's the power button?
That's still on.
Oh, there we go. Oh. So there's our little cluster that's in our database. There's a router that gives us a single point of access to the database from the application. And then maybe our administrators have VPN access through a VPN concentrator that allows them access, but it really creates kind of small pipes from the general network into where the database is. In 3.6, there's this concept of localhost default, which means that the server only listens on localhost, and in order to get it to listen to anything else, you need to bind it to additional IP addresses using bind IP. And then we talked about the application restrictions, which are essentially a form of IP whitelisting. For MongoDB Atlas, a lot of things are done for you. And I was talking to a gentleman last night with a company out in the Bay Area, and he said that they've been building their platform on MongoDB Atlas and having great success, and it absolves them of a lot of the work that you typically have to deal with in managing databases and in securing databases. It's got TLS enabled by default using the MongoDB plus SRV connection string. It's set up with Scram from the get-go. You don't have to worry about setting up authentication. The networks are isolated. It's got IP restrictions. It's got encryption, which you don't get with Community Edition. But as I mentioned before, all of the user management is direct to the users. So finally, read-only views. This addresses the surface area reduction and weak authorization risks. So with read-only views, administrators define queries that are then resolved at runtime. And the syntax is create view, give it a name, what collection it runs against, and then there's a concept of MongoDB of aggregation pipelines, and you essentially give it an aggregation pipeline kind of code snippet, and these are simpler, that can be simpler than they sound, and I'll show you one. And then you define permissions on who can access these views, and that allows you to restrict access by using views instead of direct access to collections. So to create a view, for instance, scheduler patient, the pipeline operator here is $project, and we're just projecting the first name and last name attributes into this view, and we're saying with a 1 that they're enabled. Down here, we're saying 0, national ID is not enabled. So that essentially creates a view on the patient collection where everything is visible except the national ID. So if you do a DB patient find one, where patient is the collection, you see all of the attributes of a patient. If you do a DB scheduler patient, which is a view, you just see the first name and last name. And if you do DB practitioner patient find one, which is this view, you see everything except for that national ID. So that's essentially how read-only views work. Really quick, simple overview. You can play with them and make them much more complex than the simple examples. Yep. This is the last slide. So as we kind of wrap up, we want to architect secure systems. We want our users to be confident that when they put their data into our systems, it's not going to end up in the wrong hands. Some of my data just recently ended up in the wrong hands. But many of us have had the experience of having to get our credit cards replaced or some sort of identifications replaced. And, you want to avoid that. It's very costly for your organization. So you want to consider the whole application from the UI and the service down to the database. As I mentioned, layered security is the way to go. Talking to other people in your organizations, teamwork is important. The folks who are trying to get at our data are operating in teams. Their teams are distributed around the world, just like the MongoDB folks are. So it's an organizational model that works. And being able to work together is really important. Always encrypt network traffic, always authenticate using one of the authentication models, and then think carefully about how to set up your roles so that they're effective at providing a least privilege model. So with that, I think I have a minute, and I can take a comment or a question. Yeah.
When you define the roles, can you use like wildcards for the DBs and the collections? So like if you wanted to give someone a certain type of access to all?
I don't think so. I think it's got to be done explicitly. Yeah.
Going back to how you described the PEM files before, you basically described it for one server, right?
Yes.
How would you do that in a cluster environment?
You have to create a PEM file for each. And
Each one will have its own
yes.
file. And then what about the client?
The clients each have to have a PEM file.
And you specify something in the connection string?
Yes. You do it.
All these PEM files will have to be in the same location?
Well, they have to. The configuration will specify where they are, and it has to be able to find them. I mean, you could have different configurations. Ideally, what you want to do is write a script that you can run on all your machines and put things in a common, well-known location. And you want to have that location be a pretty secure location because you don't want anybody to get your keys.
And if you have like an intermediate a CA, how would you do that? Like signing authority?
Well, you can use OpenSSL or something to create a certificate authority. I'd put that on a separate host.
But in the configuration, you can also have to specify.
Yeah, the location of the, well, yeah, you download the CA's PEM file.
Thanks.
One more question.
Okay, go ahead. Sorry.
So how can we incorporate complexity in the passwords? For example, 2 characters, 2 small characters, 2 characters.
You have to do that in your application. I mean, at the application level, you have to write code basically that says when somebody enters this string, it has to have these components. That's not really done at the MongoDB level.
Is there any way we can incorporate in Mongo shell?
I mean, I'm sure, probably not. There's probably third parties out there who've done this. I would go search for password validation algorithms or libraries that are available in the MongoDB community, because it's going to be language specific. If you're using Java or Python or whatever, or JavaScript, they're all going to be a little different. Okay, well, thanks. If any, I'll be around. So, and you've got my contact information. We'd love to work with people if they're just getting started with MongoDB and we can help. We'd love to. Thank you very much.
These guys are available, right?
Yeah.
Let's get validate.
Thanks. Thank you.